Hello and welcome to this short tutorial on MATLAB. So let's get started with the basic interface that you're seeing on your screen right now, which is the MATLAB window. The main thing over here is this left hand side is a view of the current folder. You can see whatever files are in your folder. This is the place where we will type in various commands. The workspace here shown on the right will contain all the variables, and this is a history of the commands that we have listed out so far. So let's start with the most basic functionality of MATLAB. It's just like a calculator. At the command line you could type in something simple, 1 plus 3, you see the answer is 4. So as a result of this, you can see that my history now has a record of what I have calculated, and a variable called answer, ANS, has shown up over here in the workspace. So there's a variable by the name of answer, ANS, which has appeared over here because the answer is stored as 4 in this variable. So for example, now if I were to do 4 into answer, I should get 16. That's because answer previously had 4 inside it. Okay. All right. So sometimes it can be a little unnecessary to see the output every time. So I could further do something like this. If I say 3 into answer and I put a semicolon after my command, there is no display, but you can see over here that the answer has been updated to 48. Okay. So you can imagine at the very basic level this acts like a calculator, but we are not actually interested in a calculator. We want to use the programming functionality of MATLAB. Right. So let's get started by creating a script file where we can store all our commands so that we don't have to type them in again and again. So let's go to home and let's hit on new script. Okay. So a new script has opened up over here with no name. So let's write in over here. Let's begin by writing our commands over here. Now the script file is, think of it like a glorified text file. I'm going to write in all my commands over here, and they are not going to get executed until I say execute. Okay, so that's important to keep in mind. The very first thing is comments, right? So all comments in MATLAB, they begin with a %sign. So I can say this is my comment in my first script file. Okay, and hit enter. It's like a text pad. Nothing is going to get executed. Let's save this so that we don't lose it. So I hit Control S and save it, and I say simple.m. So MATLAB script files are named with a .m extension. So now you can see that in the file browser this has shown up over here, simple. Okay. If I click on this, the first comment of the file shows up here in the description of the file. Okay. Right. So we've been through the workspace over here. Now let's start by considering how do we initialize variables. So let's say that I want to record a variable t which will hold time. So let's say t is equal to 10. Okay. So what I can do now is I can go to the editor tab over here and hit run. So when I hit run, it's just going to execute whatever is there in this script file as though it's one command after the other. So I wrote t is equal to 10, so a variable called t got created. If I had done t is equal to 10 with a semicolon, then and if I hit F5, that's the shortcut for run, what happens is that the name of the script file appears over here, simple. So I've run it, and now t is equal to 10. Okay. So usually what happens is that we want to run commands with the semicolon command, otherwise our display gets cluttered with so many output messages. And MATLAB has a way of telling you that you might get too much display. So notice that there is a small orange line over here. It says terminate the statement with semicolon to suppress output. Okay, so we'll just listen to what MATLAB says. Okay. Now this is good for a single variable. We could say that let's say omega is equal to my frequency. Let's say it's a frequency of 5 hertz. Okay, and I can say what is the value of phase is equal to w into t. Okay, let's say I won't keep the semicolon here, so that when I hit F5 over here, it will tell me phase is equal to 50. So this is simple way of producing the output. Okay, so this is how we create a single variables. Now most of the time we are not interested in single variables, but we want to do things that are a little bit more complicated. So let's take an example of that. So let's say that I want to study the behavior of some function as a function of time, and I want not one instance in time, but I want several time instances. So that would be what is called an array. So let's create an array. So there's a very simple way in MATLAB to create an array. So for example, one way would be, so I say t is equal to 1 and a colon 10. So what does this do? So let's run it and see. So it's going to run it. So you can see the output here at the bottom. So t is equal to 1 to 10. So what it has done is that from 1 to 10 it has created a set of integers. Now when I go to the workspace, I can see that t is of type 1 cross 10. That means 1 row 10 columns. The values are here, and this is the size of the data structure. Okay, I need not have only integer values. Let's say that I want to discretize time in a more finer way. So what I could do is remove this over here and 0.1 to let's say 5. So when I do this, what I'm saying is start from 1, go in steps of 0.1 all the way to 5. Okay, so if I now go to the editor and hit run, what's going to happen? So all of these, so you see the output window is full of this. So 1, 1.1, 1.2, all the way down to 5, right? So now you can see the size of t has been updated to 1 cross 41. Okay, so this is sort of helped to create a array. Okay, so we don't want to have the output displayed every time. So when I go to editor and hit run, I will just I won't see any output, but the data structure has been created. Let's say I want to clear the command window because I don't want all of these extraneous things to come. So a simple way to do that is to do CLC, that clears this. Okay, there's another important command to remember, which is clear. So when I hit clear, all the variables that are currently in the workspace will go away, right? So it's like starting from a clean slate. Okay, so usually what people do is put the CLC and clear commands at the start of their script file. Okay, so it's always a good idea to give comments along with your code. For example, I can put a comment over here saying this is time, this is frequency, and so on. Okay, so we know how to create a variable, we know how to create an array over here. Okay, there are lots of tricks inside MATLAB. For example, let's say I want to create a matrix. So let's say create a 2 cross 2 random matrix. Okay, so I can say A is equal to rand 2 comma 2. Okay, and if I hit F5 over here, or let me just do editor and run, it's going to create a matrix of size 2 cross 2 with random entries inside it, and every time I run it, it's going to produce a different matrix. This is the second time that I ran it, so you can see these numbers are different. Let me run it once more. You can see the numbers are different. So to understand better what is happening behind a function, a very simple way is just go to the command line and say type in help rand. Okay, so this is going to show you what is this function, how are you going to use it. So it says that these are uniformly distributed pseudo random numbers, different ways of invoking it, and so on. Examples are there, right? So this is MATLAB documentation is very nice and self-contained. Okay, so this is about creating a matrix. Incidentally, the word MATLAB comes from matrix laboratory. So matrices, whether they are vectors or row vectors, column vectors, matrices, they form the nuts and bolts of MATLAB. Okay, so this is about creating variables and arrays and matrices. So the next thing that we want to see is how do I visualize any function? That's kind of one of the simplest things to try to understand. So let's try to create a visualization. So for example, I have created over here a time array. The time is going from 1 to 5, let's say, seconds in spacings of 0.1 seconds. Now I want to plot, first I want to create a function which is sine of t. This is what I want to do. Okay, so let's look at the most sort of basic way in which I can do this. So one way in which I can do this is I can say, so I can create a for loop. So for I is equal to 1, 2, and I can say length of t. Okay, so if I type in over here length of t, I will get a number 41. That's because it's a 1 cross 41 length array. So I want to iterate over all the members of t. So I is equal to 1 to length t, and I can say that y is equal to sine of I, sine of t comma I. Okay, so t is my array over here, and I'm indexing it with the number I. In MATLAB, all array indexing happens and starts from 1, not 0 like in C. Alright, so I'm going to suppress the output over here and I'm going to say end. Okay, so now I'm going to go to editor, hit run. What's going to happen is a new variable y has been created, but it does not have the right size. So what went wrong over here? So what has happened is that every time the for loop gets incremented, y is a scalar and its value keeps getting updated to sine of ti. So what I should actually be doing is I should do y of I is equal to sine of ti. And now let's go and hit run. Now I get what I wanted. So y is equal to 1 cross 41. So at each of the 41 values of t, I have created a value of y. Okay, so this is what I wanted. So now let's have a look at this. There's a little orange mark coming over here, means I have done something. It's not an error. An error would be a red dot. It's an orange number. So let's see what orange says. So it says that the variable y appears to change size on every loop iteration. Consider pre-allocating for speed. So it's pretty self-explanatory. MATLAB does not know beforehand what is the size of y. So if it doesn't know what is the size beforehand, it sort of has to keep guessing and increasing the size of the array at runtime. So the better thing to do is to go in over here and declare a size for y. So let's say I initialize y is equal to, let's say, zeros. So this is how I create a set of zeros. So if I don't type anything, it gives me all the various ways in which this function could be done. So I'll say 1 cross length of t. So I want to create an array, right, of size 1 by length of t, and you see the orange mark has gone over here. So when I go to editor and run, same thing as before, no warning messages. So this is one way of doing it. Now in MATLAB there is an even smarter way of doing it. So let's write down even smarter way of initializing, and that's simply a one-line message, and that's going to be y is equal to sine of t. That's all I need to do. Okay, so if you don't believe me, what we can do is let's call this, give this a different name. Let's call this y underscore smart. Okay, and let's go and hit run. Okay, right. So we can later compare whether y and y smart are the same. So what we could do is we could find out. I'll just type this into the command window. So I can create a new variable. Let's say diff is equal to y minus y smart. Okay, and you can see that there are zeros everywhere. So that means that both ways of initializing this array are the same. So let's not bother by creating a new name. Let's just call it y is equal to sine t, and this is the way in which we have initialized it, right? So now let's plot this function that we've got, because that's what we're interested in. Okay, so let's say plotting this function. Okay, by the way, the sine of 5t it's not just sine of 5t. You could have done something like 1.1 sine t or whatever you wanted, right? So to plot this, MATLAB has very nice built-in plotting library. So all you need to do is, so if I type in plot and just wait for a second, it will show me the various ways in which I can fill it. So plot wants a set of x comma y, right? So what is x? It's time, and what is y? it is so the y-axis is y itself, right? So if I just hit enter over here and let's run this, what's going to happen? So it's plotted, right? So it's plotted. This is exactly what I would have expected of the sine function. Note that I did not start time from t is equal to 0. It started from 1, right? So that's why it's not starting from 0. It's gone over here. Now, now there are several things I can do to make this graph a little bit more informative, right? So for example, let me go over here. So let's put down, let's get a grid on it. Okay. So what does grid do? We will see. We want to give it an x label. So x label is time. Okay. So you can even put in, let's say, the units, and y label we can say function value, right? And let's go and hit edit again and run, right? So now the figure is here. So grid has made this nice sort of graph paper like grid over here, so it's easier to read numbers, and the function values appeared here, time is appeared over here. Okay. This is sort of the basic way in which I can do this. Let's say I want to make this red in color. That's also very simple. I go to the plot function and I give it a third argument, and I say give it a red color. Okay. Let's look at this, and it's become red in color over here. Okay. So if you go into HelpPlot, you will not plot. So HelpPlot. There are lots of different ways in which you can add markers, different colors, different thicknesses, etc. over here. All of this is very easily accessible in the help command over here. Okay. So let's do a few simple things now. Let's say that I wanted to plot two sinusoidal functions. Right now I've plotted one sinusoidal function. So let's before I so what I'll do is, okay, let me start here. So plot another function on top. I want to plot it not as a separate figure but as an overlaying figure. And what is this function that I want to plot? I want to plot, let's say, z is equal to sine of let's say the same frequency, okay, but with some phase difference. So let that phase difference, let's say I can take any number I want. Let's say z is equal to this, right? So when I do this, a new variable z is going to get created. Okay. Now if I write, if I type in a plot command after this, what will happen is it will overwrite the previous plot. I don't want it to overwrite the previous plot. So I want to, what I will do is I will say I will type in hold on. So hold on is going to keep the previous plot alive, and then I'm going to say plot of t comma z, and let's have it plotted in blue color, all right? And let's see what happens. So let's go to editor, let's hit run, and there you go. So you have the red plot, which is your sine of 1.1t, and then I plotted a blue curve z, which is the original sine function with a phase lag. So you can see the blue curve over here given by z is lagging behind a small amount, right? So you know, I can't always keep track of what is blue, what is red. So there's a simple way of doing it. I can add a legend to the plot. I can say legend. So the legend is to be specified in the order in which I have created the variable. So I can say y comma z. Okay. So let's go and hit edit again, and right. So you can see that the legend has appeared over here. Okay. A convenient way to start from fresh every time is, as I mentioned, that I can always start with clearing the variable so that there is no confusion, and I can also close all previous plots that were there. All right. So now when I go and hit run, right, there you go. So it has created a figure with the grid over here. If I don't put the close all, and if I don't put clear, what will happen is that the hold on will keep getting toggled, you know. So if I type in hold, so supposing I type in hold, it says it will release the plot. Now if I type it once more, it will hold it, right? So this hold function, it acts as a toggle. So that's why it's better to do close all and then start your new plot like this. Okay, so this is your basic way of plotting functions, overlaying functions. There are several ways of doing it. I've shown you the simplest way. The last thing that I want to show you is how do you create functions in MATLAB, because they functions really allow you to explore various possibilities of complicated functions. Okay, so right now, for example, I created a function z, which was very simple in this case, but it could be more complicated. So let's try to do the same thing by means of a function. Okay, so now we will create functions. Okay, so depending on how complicated functions are, we can have different strategies. So one strategy, as we saw, was to simply type in the function explicitly in this way. Right? Another way is what are called anonymous functions. Okay. So what is an anonymous function? I can create an anonymous function as follows. I can say w is equal to, so w is going to be, let's not call it w, let's call it function. Okay, so fn. This function is, let's say it's a function of time t, and once you give me t, what do I want to do with it? I want to do something like t plus cos t. Okay. So what does this mean? This means I've created a function, right? So which takes in one argument and evaluates sin t plus cos t. Okay. So now if I want to plot this, so we already have one plot window open, and I want to create a second plot window. So what I do is I type in the command figure. This will create a new figure when it is run. And now what I can do is I can create function values. Let's give it a name fn vals, and this can be function t. Okay. So what will this do? It will evaluate the function with the array t. Okay, so maybe this might be a little confusing. Let's just change this variable x. So this is a dummy variable for the function definition, right? So this is definition of function. Yeah. Okay. So what does this tell you? That it's going to create an array called function vals, and it's going to take as argument the entire array t. Remember, t was a 1 cross 41 array, and it's going to put in the value into function vals. And then once I've done that, what I want to do is I want to plot t and function vals. I like the grid as before, and I want the x label to show me time, and I want the y label to show me function. Okay, so I've written all of this in one line. It's a matter of convenience how you want to do it. Let's hit run. So it's created two figures as before. The first figure is there in the script file, so it's created one, so they can minimize it. This is the new figure that it has created, and this is a plot of sin t plus cos t as a function of t. Right? So these are the function values. You can see sin t plus cos t can exceed 1 or minus 1, and that's what we're seeing over here. Okay. So this is how to create functions using anonymous functions. Okay, so I gave you an application example in terms of plotting, but you need not plot. You can use this function definition in whichever way you want. So you can see this function definition has been created here in the workspace with a different symbol. It's a function handle. Now let's say that I wanted to achieve the same functionality, but by using a different way. So what I can do is I go to home and I say create a new function. So it's going to create a new function, and this is the sort of template that MATLAB provides to you. So we had given so let's say let's call this function from file. Okay, so function from separate file. Now input argument 1 and input argument 2, this is up to you how many input arguments you want to give. So we want our input argument only to be 1, which is x. And our output argument, we have only one value, so this is y. Okay, so let's remove these comments over here. We can say compute y as a function of x. You should always have one line of a comment explaining what your function does, so that someone else who's reading your file can understand what's going on. And remember, what I wanted was y is equal to sine of x plus cos of x. Okay, so That's done. Now this thing is not saved, so when I do Control S to save it, it will hint that it's already given me the name over here. So the name of the function and the name of the file, it should be the same, except that the file has a .m attached to it. So I save this. Okay, it's gone into the same directory as you can see on the left. So now, so this is, for example, using function. Now let's do the same trick as we did before. So I can say hold on, okay, or let's just say hold, and the on is not necessary. And I can create another array. So let's call it function vals 2, and instead of using the function fn over here, let me use the function from file. So I can say fn from file, and I give it the same variable t. So it's going to take in the array and the entire 1 cross 41 array, and it's going to compute as output over here the a new array. So remember, nowhere in over here have we specified that x is going to be a scalar or x is going to be a vector. It can be anything as long as this function is defined. So for example, if x instead of being a scalar is a vector, then y will also be a vector. If x is a matrix, then y will be a matrix. As long as the intermediate connections, for example, as long as addition is defined between a matrix and a matrix, it won't complain. However, if I do, for example, sin x into cos x, then that may not work if I give x to be a matrix of the incorrect size, because then matrix multiplication will not be defined. So you have to make sure that the function is correct from your end. And so now we have calculated the function value and put it into a second variable name called function vals 2, and we have already done hold. So now let's add this guy to the plot. So t and function vals 2. Okay, and to distinguish the colors, let's go and give this guy a red color, and let's give this guy a blue color. Okay, let's go to the editor and let's hit run. Okay, so well, as you can see, these two functions were identical, so they're sitting on top of each other. How do I know that? So let's create a legend over here, and let's call that 1, and from file, so that I know I can at least the legend will tell me what is where. All right, so I run this once again, and you can see that right, so they are sitting exactly on top of each other. That's why you see only one color over here. If you wanted to yeah, okay, so I think this is good enough to give you a handle on the basic usage of MATLAB, which is, if we review it, this is, we started by creating comments, clearing the workspace, closing any windows that might be open. This is how I create a single scalar. Then I have an array. I can choose the spacing between the array elements, okay, and I can create a matrix like this. I have a way of initializing, which was by means of a for loop. There are other kind of loops also possible in MATLAB, like while loops, and then plotting this function. And these are the ways in which I can plot the function. I use the hold command if I want to hold the plot on. And we learned how to create functions, simple functions using anonymous functions. Here it can be defined in just one line, so this is all I use. The second way in which we define the function was by using a separate file. Typically, in realistic applications, the functions that are defined in files, they can run into hundreds of lines. So it's not going to be possible to use a anonymous function like this, which typically is defined on just 1 or 2 lines. So that's the power of functions over here. And you can see that this is an interpreted language. There is no need to compile anything. You just write this over here. It's saved always as you create it, and yeah, that's about it. So this should get you up to speed with the basics. One thing I did not tell you is how do you create a complex number. So before I close this, I will show you a simple way in which a complex number is created. So the simplest way is for me to type in over here into the command line window. So let's clear this first. So let's say a is equal to 1 plus 1i times 2. Okay, So this is the simplest way in which you create a complex number. So you put in 1i. This is to indicate the complex number I. You can do 1i or you can also do 1j. It works just as well, right? The same number is created over here. Everything that I've spoken about so far can also be done with complex numbers. So creating arrays, plotting, etc. Everything can be done with complex numbers. So this this brings to an end this part of the MATLAB introduction. Thank you.